Hey everyone, welcome back to my YouTube channel. One of the major benefits that Jetpack Compose provides is that it allows us to cater multiple screen sizes with one single code base. In XML, when we had to create multiple screen sizes, we had to create separate layout files. Well, not anymore. Wondering how do we create adaptive screen sizes, clean theming, and use resources in our app? Stay until the end of this video where we will discover exactly that. Starting with the video, as you can see that I have absolutely nothing onto the screen. This is the most basic setup that is provided right out of the box when you start a new empty project in Android Studio. Now in this video, I'd like to talk to you about the clean theming, that first of all, how can we create our own custom themes? And then secondly, how can we make our custom theme follow a clean architecture? Now, when I talk about the themes, you can see that we already have a material theme that is in place. Now, this material theme consists of the colors that are predefined in the app, the typography that this app would be following by default, etc. Now, the thing is that we would like to change this. In XML also, we used to do this, if you remember, by setting up our own custom themes in the themes.xml file. Now, when we open up the styles.file in a Compose app, you'll see that in Compose, we only set the status bar color for our app, and then everything, all the colors, fonts, etc. are all controlled by the material theme that is defined by the app by default. Now in here, we'll see that everything seems to work fine. Well, the thing is that when we wrap our composables with this theme, all the colors and typographies, etc. that will be picked up by default will be whatever we defined in our theme. So we can override these values to create our own custom themes as well. So in the color.kt file, you'll notice that I have added 2 more colors, and I'm going to change these colors as the default values. So in here, you'll see that I have changed the colors to default values. Let's go ahead and run the app now. Now, if I run the app, you'll see that the default colors have been changed. When the whole app has to follow a single theme throughout, then it makes most sense to define a custom theme once and then use it throughout, without worrying about styling or things like that. Most of the times, what happens is that when we define any style, we also need some extra parameters which we would like to use throughout the app as well. One of them is spacing. So generally in our development journey, we would like to create some common space values so that they can be used throughout. So if you notice that I have created a spacing class with some regular spacing values, and then I have used that in the main activity when I had to use the padding values. One way to use these values are by instantiating the class every time and then using the values, which we are doing right now. Obviously, this is not the right way to do this. This method would result in unnecessary overhead since we would have to instantiate the class every time. Moreover, the composables would result in unnecessary deep argument trees if we try to provide the spacing class using the dependency injection principles. So what do we do? Well, one thing that can be done here is that if we could somehow pass this spacing class to the material theme, then we could use the spacing values just like we were using the other parameters of the material theme class. One more thing that we can do is to use the composition locals. So if you notice here that I have first created a composition local of spacing and then used local spacing.current.extralarge as the value for the padding. So what is happening here? Before we understand that, we will need to take a look at what are composition locals. Hey guys, just a quick pause here. Just want to tell you that if you're interested in learning about the advanced concepts of Jetpack Compose, such as creating our own animations, gestures, views, and layouts, then do check out my course. The link will be in the description box down below. Now, back to the video. Well, composition local is a tool for passing down the data through the composition implicitly. Usually in Compose, data flows down through the UI tree as parameters to each composable function. This makes a composable's dependencies explicit. This can, however, be cumbersome for data that is very frequently and widely used, such as the color or type styles. Well, in even simpler terms, we know that since the data is flowing down, which is the case for most of the declarative programming languages or frameworks such as in Flutter, data flows down. That means if this is the UI tree, then everything is scoped to a particular component. So that would mean if we define some values in this component, then the parent component would not be able to use it. Moreover, let's say if all the components need to use the same variable or value, then it needs to be passed down. Most common example would be the use of colors. Now, if we pass down all the values, then obviously it would result in unnecessary deep argument tree, which would easily become very hard to manage. So, to support not needing to pass the colors as an explicit parameter dependency to most composables, Compose offers composition locals, which allows you to create tree-scoped named objects that can be used as an implicit way to have data flow through the UI tree. Now, in simple terms, basically composition local creates a local scope from the point of definition so that everything can be wrapped under that scope. That means if we want to use some values throughout the app, then we could wrap the entire app with composition local. Otherwise, we could wrap all the composables which need to use those values. Now, there are two ways to create a composition local. The first is composition local off. Changing the value provided during recomposition invalidates only the content that reads its current value. The second one is static composition local off. Reads of a static composition local are not tracked by Compose. Changing the value causes the entirety of the content lambda where the composition local is provided to be recomposed instead of just the places where the current value is read in the composition. If the value provided to the composition local is highly unlikely to change or will never change, use static composition local off to get performance benefits. Now, if we head over to the material theme file, we'll see that all the values such as colors, typography, etc. are all provided by composition locals. So similarly, if we want to create our own composition local for spacing class, we can simply create an extension function to do that. So here you can notice that I have created an extension function to provide our spacing class, and then I have used that accordingly in the padding composable. Now that we are somewhat aware of the composition locals, let's take a look at how can we make adaptive screens. So basically, the local configurations already provide us the current screen width and height. So we can use them directly to create our composables for different screen sizes. That's one more added advantage of using Jetpack Compose over XML, that it has made creating UIs for multiple screen sizes much easier. So let's get going. So as you can see here that I have now created a new file, remember window size. And then inside that file, I have created an enum class for the window sizes I am targeting. Then I simply create a state to remember the current window size. This window size is based on the screen height and width which is provided to us by local configuration. Now also notice that the values that I'm using for the width and height are actually taken from the Android documentation itself, and these are not some values that I'm making up by myself. Now in the spacing file, I create a simple interface for the purpose of this video. So basically, since I just want to work with extra large spacing values, that's why I moved everything else to an interface. Also, I did this because now I can have multiple values from same class. I'll explain what I mean by that. Also notice that I have used different composition locals for different spacing classes that I have created as well. In here, you can notice a few things now. Creating everything into one single interface has provided me the liberty of using single extension function for all kinds of composition locals now. Also, you'll notice that I have removed the read-only composable annotation. Well, that is because read-only composables can only call other read-only composables. So currently, our remember window size is not a read-only composable. Now, for the purpose of this video, I have removed this, but when in production, it's best if you use the read-only composable so that the value of the composables cannot be changed from outside. Anyways, now if I use the extra large value for padding in the main activity and build and run this app in both tablet and the mobile device, you'll notice that how the screen automatically applies different values for padding based on the different screen sizes. So this is the screen for the mobile phone, whereas this is the screen for the tablet. So you can see here that in the tablet, there is much more padding applied when compared it to the phone. Now you can similarly create composables for different screen sizes and show the respective composable based on the different screen size. I'll leave that up to you to try. And if you face any problem, remember that you can always comment in the comment box below or join my Discord server if you want to have a one-on-one chat. Link to the server will be in the description box down below. So let's keep the video until this point. I hope that you learned something of value in this video. Thank you for watching the video and for your time. We'll meet in another video. Until then, keep contributing code to humanity.